Okay, so in this video, we will take a look at another case where we can use the cosine rule to solve problems involving triangles. And in this time, it's quite obvious. Okay, if all three sides are known and there's no angles given at all, then it makes it virtually impossible for you to use sine rule because there's no angles for you to form your fractions. So then definitely you will use cosine rule itself. Okay, so let's take a look at this question. So in triangle ABC, A equals to 10 cm, B equals to 9 cm, C equals to 14 cm, find the angles of A, B, and C. Okay, so if I have the following diagram, okay, let's just label them as A, B, and C. Okay, so the length A is opposite the point A itself. The length B is opposite the point B. The length C is opposite point C. So this is simply 10 cm. This is 9 cm. And this is 14 cm. Okay, so if I want to find this angle over here, then my right hand side of the cosine rule must be this length over here. If I want to find this angle over here, then my left hand side of the cosine rule must be this angle over here, this length over here. Okay, so because they already label for us A, B, and C, let's use that as our uh, working. Okay, because it's nicer. So by cosine rule, we will have um, a square equals to b square plus c square minus 2bc cosine a. So a square is 10 square, b square is 9 square, c square is 14 square minus 2, 9, 14 cosine of angle BAC. Okay, moving everything to the left hand side, I have so 2 times 9 times 14 is simply 252. So I have 252 cosine angle BAC. So I have shifted this to left hand side. I have 9 square plus 14 square minus 10 square on the right hand side. So 9 square plus 14 square minus 10 square equals to 177. So cosine angle BAC is simply 177 over 252. Okay, so angle BAC equals to cosine inverse of this particular number. So I have 45.382 degrees. Okay, so 1 dp. So we can use the same exact thing to find all the other lengths, all the other side itself, all the angles itself. So if I want to use cosine rule, okay, I'll just have to copy this whole thing. So let's copy this whole thing. Uh, Control C, let's paste it here. Okay, so let's copy the whole thing. And instead of add 10 square, we will erase 10 square. Okay, we will erase the um, 9 square because the length opposite angle ABC is 9. So the 9 should be on the left hand side. And this is of course angle ABC. Okay, then everything else is changing. Everything else we can just erase lah. Okay, I'm just doing this because I'm just I don't feel like rewriting everything again. Okay, so what happens is if I want to use cosine rule to find the next angle, so this one will be 9 square because it's the length opposite the angle that I want to find, which is angle ABC. And this will be 10 square and 10. Okay, so I have 2 times 10 times 14, so 2 times 10 times 14 should be 280. So 280 cosine angle ABC is equals to 10 square plus 14 square minus 9 square. So 10 square plus 14 square minus 9 square, I get 215. So cosine angle ABC is equals to 215 over 280. So angle ABC is simply cosine inverse 215 over 280, which will get me 39.838 degrees, which is equal to 39.8 degrees. And of course, angle ACB equals to 180 degrees minus 39.838 minus 45.382, and I will get 94.78, which is simply 94.8 degrees. Okay, so yes, that's it. Okay, of course, at this point of time, can we use from here? Okay, once we are done with this part over here, okay, instead of going it this way, can I instead use use sine rule? Okay, because once I have this angle, which is 45.382, once I have this angle, is there a possibility for me to use sine rule to find this blue angle over here? And you realize you can actually do it. So by sine rule, so this will be an alternative method. Okay, so by sine rule, I will have the given length angle. So I want to find angle ABC. So sine of angle ABC over 9 cm. So AC. Let's just write down everything properly. AC equals to sine of angle BAC, which is what we have found, over BC. So sub in all the numbers, I have sine angle ABC over AC. AC is 9 cm equals to sine of angle BAC, which is 45.382 over BC, which is 10 cm. Multiply by 9 throughout, I have sine angle ABC equals to, so sine 45.382 divided by 10 multiplied by 9. So sine angle ABC is equals to 0.64062. So angle ABC equals to sine inverse. Of course, in this case, because we are using the sine rule, okay, we must remember to use the obtuse angle as well. Okay, so you will have 39.838 degrees, which is what we found. Okay, or 180 minus this one, so 180 minus this answer will be 140.162, and you realize that you will reject because of simply the fact that 140 plus 45 is more than 180. So you realize that, hey, I still arrive at the same exact answer as what I found if I use cosine rule. So over here, I have the same exact answer. So which one is better? Okay, honestly speaking, there's no right or wrong method here. There's no one way is better than the other. For my preference, I prefer to work with sine rule. Okay, but for some people, because their algebraic manipulation is much better, they prefer to work with cosine rule. So you realize that so far we've been through four different cases. If let's say I say that two angles and one side is given and I want to find unknown length, then I will actually use the sine rule itself. If I want to find unknown angles and I have two sides and a non-included angle, then I will use cosine rule. I'll use sine rule as well. But if I'm given two sides and included angle or three sides even, then I will use cosine rule. But in this case, why is it I can use sine rule and cosine rule? It's simply because at the end of the day, in this case, you realize that once I found the angle over here, I will have three sides and one angle. And three sides and one angle can fulfill either this one or this one, two angles and one two sides and one good angle. So basically, as long as I have a wealth of information on my side, I can be free to use whichever rule I want. Okay, and they should arrive at the same answer itself. Okay, so I hope this clarifies some questions that you might have. Of course, another question is how come I didn't have, you see this part over here, I have this or thing here, but over here, why is there no or? Okay, why is there no or over here? Okay, and the reason is simply because if you recall back, I have the following: cosine 180 degrees minus theta equals to negative of cosine theta. Okay, because the cosine of the acute and the cosine of obtuse is not the same. The sign is different. I don't have to consider the or over here. Okay, so I hope this helps to make clear things up. Okay, do let me know if you have any questions with sine and cosine rule, or areas of triangles for the matter of fact. In the next last video on this chapter, we will summarize everything that we have done thus far for trigonometry itself. Okay,